like the random variable less than a number. So the question would be, what is the CDF, the conditional CDF of x, given that x is already known to be less than a specific number b? And we had two cases when x is larger than b, then this basically conditional CDF becomes 1, and when x is less than b. And basically we gave an example and we discussed the issue of that the conditional CDF in this case, in the range conditioning, cannot be smaller than the CDF. So it's either 1 or larger than the CDF, because conditioning decreases the sample space, the values of x that can x take, and hence the conditional CDF increases accordingly, or stays the same at least. And then we differentiate this CDF, conditional CDF, to get the conditional PDF. We gave an example and we stopped at the second example. So today, inshallah, we'll finish up the example and then we'll go to chapter 3, start chapter 3, which is the operations in one random variable. This is what we'll do, inshallah, today. So the example that we started, but we did not have time to continue, is about a target. So basically here we have the target, which is if you shoot and you get the bullet anywhere within this larger circle, the bigger red circle, which has a radius of 50 meters. Okay, so this is basically the big target, and the bullseye target, which is the smaller red circle, has a radius of 10 meters. Okay. Now, if x of x, or the distribution of getting into the target, or basically if you shoot, the distribution that you get any number at anywhere in the x-axis close to at any x, let's say if this is x, at any x between 0 and infinity, is given by this function. Okay, so basically, which is a Rayleigh function. So basically, it's 1 minus e to minus x squared divided by 800. So now let me repeat this CDF. What does it mean? It gives you the probability that it's this CDF of x. It gives you the probability that if you shoot, you get at anywhere on the x-axis from the 0. Okay? Of course, it goes all the way. So basically here, in all directions. Okay? So for example, the probability that x is less than or equal 10 would be fx of 10, right? Which is 1 minus e to minus 10 squared divided by 800, which is 1 minus e to minus 100 divided by 800. 100 divided by 800 is 1 minus 1 over 8. This is the probability that you get within this small circuit, circle of 10 meters, and so on. So now the question that we are interested in is, given that I landed in the target. Now the first one here that I just solved is the probability that I land in the bullseye. So this is what, let us write it in probability to land in bullseye. This is equal to the probability that x is less than or equal to 10. Now, if I'm interested in, given that I land in the target, so the bigger circle here, given that I am in the bigger circle, I landed in the target, what would be the probability that I hit the bullseye, which is the smaller circle? Okay. As we have done before in the conditional CDF, this is equal to, now here the condition is x is less than b. So b here is 50, x is 10, right? So x is less than b. And because of that, the answer is fx of x divided by fx of b. And you don't need to remember this. You don't need to remember this. You can always get it by remembering that when x is less than b, basically x less than b becomes, or this, sorry, x less than x becomes a subset of x less than b. And hence the intersection of the condition in the numerator of the conditional probability will be this one, which is f of x. So basically here fx of x given x less than or equal to b, this is the way you remember it, huh? Is equal to the probability that x is less than or equal to x intersect x less than or equal b, right? Divide by x less than or equal b. And we know now the intersection here, because this one is a subset, it will be probability that x is less than or equal small x. Divide by probability x less than or equal b, which is fx of x divided by fx of b. So nothing to remember, Shabab. It's all about understanding. Do you understand how did we do this? You can always get the final answer. So now the question would be, given that I landed in the target, what will be the probability that I land in the bull's eye, in the smaller red circle? It is fx at 10 divided by fx at 20, which is just by substituting in the numerator and denominator, and I get this. Okay, which is 12.3%. Now anybody, Shabab, can calculate for us what is the probability that we land in the bull's eye without the condition, which is here. I just calculated above. Anybody has a calculator next to him, he can do this for us, just to compare the conditional with the non-conditional. Shabab, any volunteer?
Yes, Doctor. 0.1175.
0.1175, which is 11.75%. So basically, without knowing that I am in the target, the probability that I hit the smaller red circle is 11.75. Now, if I know that I already landed in the target, the probability increases that I hit the smaller circle. Okay? واضح يا شباب الفكرة هنا؟ الإكزامبل؟
Yes, but
تفضل.
it did not change much. I mean, it
Yeah,
increased a little bit.
In this problem, this يعني doesn't have to change much. يعني مثلا خلينا نقول إنه التارجت مثلا instead of 50 meters, let's have it 30 meters. In this case, it will have a big difference. Okay, because this denominator will be larger, it will be smaller, and hence you will have a larger probability. And logically, the target becomes smaller. So given that you are in the target, is a big chance that you are in the, becomes bigger chance that you are in the smaller circle. So try it, Shabab. Try 20 meters. Try the target as 20 meters. And calculate again, please, the probability, the conditional probability. Anybody can do it for us? So the only thing you need to change is the denominator. 20 meters, it will be 1 minus e to minus 400 over 800.
0.2986.
Of 0.298. 298, which is 29.8%. You see, it's much larger because now the target is much smaller, and hence, knowing that I am in the target, the probability that I hit the smaller red circle becomes larger and larger. واضحة؟ بينما لو التارجت أخليه 100 ما حتفرق هذه ساعتها الكونديشن والنون كونديشن. Because the target is already very wide. So knowing I am in the target, It's okay, doesn't matter, doesn't add any much information. واضح؟
Yes.
طيب ممتاز. أي سؤال ثاني يا شباب؟ طيب. The last thing I wanted to mention about the histogram. The histogram is a graph that basically shows the distribution of a specific random variable. So for example, here we are generating n samples, and we are calling f, which is random variable, as rand n. Rand n here is the Gaussian or the normal distribution. So rand n here is a normal distribution with zero mean and unit variance. Unit variance because it's one here. And the default is zero mean. Now, if you plot the histogram, hist, f is the random variable, and 10 here is the number of columns. Which columns? Let us see. If I plot the PDF looks like this, a continuous, nice, for example, this is for daily, not for this example. PDF will look like a continuous function. However, the histogram will plot for you an approximation of the PDF, which basically takes the vector اللي هو n, very long vector, 1 by 100 by 1000, and finds how many of these within this range, and plot this as a column. How many of these 1000 points are within this range, and plot it as a column. How many of these numbers are within this range, and plot it as a column, and so on. So eventually it gives you very close to the PDF. So this is for this specific sample, for this specific vector. As the vector becomes longer and longer, the histogram will fit more into the data, or into the original PDF, into the real PDF. So for example, if you have 1000 data points, 10,000, sorry, you will find that it is much more smoother. And this is using, for example, 10 columns. If you use 100 columns, then basically these will be much smaller, these parts. So instead of dividing it into 10 columns, 10 areas, 10 columns, it will be مثلا 100 columns, which will make it smoother histogram. واضحة فكرة الهيستوجرام يا شباب؟ So try this in your MATLAB, try to play with it and see how things will go with you. Try to play with the parameters, generate some random variables, try to play with these things. It's very nice to have some experience. Now this is a histogram of a uniform random variable. Now this is divided into how many parts? How many columns you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here are 10 columns. If you use 100 columns, it will be much more smoother. So the idea of histogram, it goes into the vector that you generated, which is a random vector, and finds how many of that vector lie within this period of numbers, and plot it as a number, as a column. How many lie between 0.1 to 0.2, and plot it as a number. As the length of the vector becomes larger and larger, and as you have more columns, you will find that it becomes more smoother PDF. Histogram. Sorry. Any questions, Shubham? Any question?
No, doctor.
طيب ممتاز. طيب, so now let's go to chapter 3. You have nothing to ask. Any question about chapter 2 in general يا شباب؟ أي أحد عنده أي سؤال استفسار؟ So chapter 3 is about
يرحمك الله.
Chapter 3 is about operations on one random variable. So until now, we discussed only one random variable. In chapter 4, we will discuss two or more random variables, which we call them multiple random variables, and their relationship and operations on them and so on. So here we are mainly concerned with operations on one random variable. And this is chapter 3. Okay, mainly what we call expectation. And of course, we'll talk about more than expectation, but expectation is the first important part. So what we will discuss in chapter 3, and first of all, a little bit of introduction, and then expectation. We'll define what expectation is and how is it applied to random variables. And then we'll define moments, among which we'll talk about all the different moments that we have already talked about, مثل variance, mean, and standard deviation, and much more. And then we'll talk about functions of moments. And then we'll talk about transformation of a random variable. If I have a current that is random, and I'm interested in the power, or if I have a voltage, I'm interested in the power. If I have a linear transformation, and so on. So transformation of random variables in general. And then we'll end with some how to generate one random variable. Okay, so the expectation is the way we write it. Before we go into the expectation, now let's assume that we have this example. Now I have certain people, and every one of them carries certain amount of money. Okay, so the number of people carrying 18 cents is 8 people. Number of people carrying 45 cents in their pockets are 12 people. Number of people carrying 64 cents in their pockets are 28 people. Number of people carrying 72 are 22 people, and so on. Tamam? Now, how do I calculate the average number of cents people carry? The average of what? The average of number of cents people carry. How do I do that? Simply, I look at every group of number of cents, 18 for example. Here the average number of dollars. Dollars, not cents. So 18 cents is $0.18, and I multiply by the number of people carrying this divided by the total, which is the probability that x equal 0.18, right? And then I add to it 0.45 cents, and I multiply by it the probability that x is equal to 0.45. 12 out of 90 people, here 90 total. 12 out of 90 people carrying 45 cents or $0.45. After that, the next amount of dollars, 0.64, multiplied by the number of people carrying $0.64. And then $72, $0.72, multiplied by the probability that x equals 0.72, which is the number of people carrying 72, 22 divided by total, and so on. So the average gives me this, 0.632. So what did I do in general? What I did is, in order to calculate the average, I summed over all the values of x equal 1 to n. I multiplied every value of x by the probability that x equals xi. Eventually, this is what I did in order to calculate the average. Similarly, in your exams, the way we calculate the average is we take every score, every common score that different students have gotten, and we multiply by the number of students who took this score, who got this score, divided by the total number, which is the probability of them. And we add the next score multiplied by the number of students who got the score, divided by the total number of students, which is the probability, and so on. So the way we calculate average is this in discrete random variables. واضحة الفكرة يا شباب؟
Yes, clear.
I bet you know this before. But now this average, this has many different names. It is called expectation of x. It is called expected value of x. It is called mean of x. It is called statistical average of x. All these mean the same thing, the average of x of a random variable. Okay? Now, expected value, the word comes from the notion that for this random variable, the expected value اللي هي typical value المتوقعة اللي هي الافريج. So الفاليو المتوقعة من random variable هي average value. And this is why they call it expected value. And the operation that we just did is called expectation. اللي هي the process of averaging when the random variable is involved. So what we did here eventually is we calculated what we call expected value of x. So we averaged out using the statistical properties of x. This is the average of x, or this is the expected value of x. Now this operation, this here is called expectation. Expectation operator. Expectation operator. And the result, if we put x inside here, gives me the mean, the average. هذا هنا نسميه mean أو average أو so on. So the average in general can be written as expected value of x or x bar. هذول كلهم اسمهم المين. هذا هنا mean, average, expected value, and so on. So whenever you see in this class, in the coming lectures up to the end of the semester, and whenever you see it in your life, x bar means it's the mean, the average. Expected value of x means the mean or the average. Okay?
اوكي
So-
دكتور.
تفضل.
اوكي
ممتاز. شباب, feel free to interrupt me if I'm going fast or something is not very clear. So for discrete random variables, the expectation operator works like this. I sum over all values of x, and every one of them I multiply it, I give it a weight with its probability. نفس اللي سويناه تحت في الإكزامبل هذا. Exactly. For continuous random variables, I will do the same, except that I replace the summation with an integral. So it will be integral from minus infinity to infinity of x multiplied by the PDF. Very similar to what we did in the continuous. So in continuous random variables, we replace summation by integral. Like in the same thing, we are averaging over the random variable. Now this is called E of X is what we call expectation operator. Later we will find that we can always put anything inside. So instead of E of X that gives me the average, I can put E of X squared, which will give me something else. Okay? And so on. We'll talk about it when we reach. I don't want to. So the average or the expected value or the mean of a random variable is calculated for discrete random variables as the summation of different values of x, each one weighted multiplied by its probability, or by integrating over x multiplied by fx by the PDF. Okay, this gives you the average. Now for symmetric PDFs, symmetric means like this. Around certain number, the shape to the right of it is the same as the shape to the left of it, or the area of the shape. So basically fx plus a equals fx of minus x plus a for all values of x. So around a. In this case, the expected value is a. And it's equal to the median also. For this case, in this case only. Not necessarily. In this case only. تتذكر الميديان الوسيط اللي هو the number at which the probability that the variable is less than that number equals the probability that it's larger than that number. اللي هو يقسم ال PDF into two equal halves. For symmetric PDFs, the expected value or the average equals the median. Equals the average value, expected value. طيب. Any question? طيب, let's now take, we already gave you a discrete random variable example. Let's talk about continuous random variable example. We have an exponential distribution, تذكر exponential, who basically looks like this. At A, it starts decaying. One over B. تذكروا هذا? So basically, let's find out the expected value of the exponential. So it's 0 before A, and after A, it is this function. Now, in order to find this, simply expected value of x equals the integral of the PDF, this is fx of x, multiplied by x for averaging. Find the average. And I integrate from A to infinity because the PDF starts from A. Now, in order to do this, simply I can remove everything that is constant, اللي هو هذا. E to minus A over B, which is E to A over B. أقدر أطلعه برا because it's constant, divided by B, which is constant. So these are constant. I just طلعتها برا. Constant. And I am left with integral of E of x, E to minus x over B. Now, using this integration by part, I can basically, I'm giving you this this is basically how to solve it in case you forgot from your calculus. So basically, integral from of x e to cx is given by this. I just replace c by 1 minus 1 over b. I get the same integral here. So the solution to this is basically given by this. Now if you simplify, you get a plus b. a plus b. تتذكر احنا قلنا الافريج was a plus b. So if a equals 0, it was b. So the average would be here, a plus b. So clear how did you do it? Any question? معايا يا شباب؟
معك دكتور.
Yes, with you.
طيب
Yes.
ما في أي سؤال؟ كل شيء واضح؟ طيب. So now what about if I have a function of a random variable? So in this case, the operation on the random variable is itself as a random variable. So مثلا يعني let me have x as my random variable. Y, which is equal to g of x, g here is a function. Is a function. Y, which is g of x, is also a random variable. لأنه يعتمد على random variable. يعني مثلا if x was a random variable that has equally probable numbers 0, -1, or 1. Okay? Then if I define y to be g of x, which is x squared, then y here is a new random variable, right? First of all, let's calculate what is the expected value of x. Shabab, send it to me over the private chat. I need the expected value of x. Calculate it and send it to me over the private chat, please. Expected value of x. ما جاني إلا جواب واحد الآن. Quickly. Wow. First time that the answers are all or mostly wrong. Shabab, how do we do this? What is the expected value of x? اللي سميناه نحن x bar average. Expected value. How did we do this? يا شباب, we sum over all values of x multiplied by the probability of x equal that value. Right? How many values this x takes?
-1, 0, and 1.
So 3 values, right?
Yes.
So it's -1. What is the probability of -1?
1/3.
1/3. Plus 0. What is the probability of 0?
1 over 3.
Excellent. Plus 1 آخر value. What is the probability of 1?
2 over 3.
ليش 2 over 3? 1 over 3.
Yes, 1 over 3.
They are all equally likely. So we have here minus 1 over 3 plus 1 over 3. They cancel each other and they get 0. Right? Only one student got it right. The rest are wrong. Shabab, yeah, you need to pay attention, or if you don't understand, let me repeat. But just being silent doesn't help you at all. Exams are approaching and everything will be clear to you at that time. So please, let us help each other so that you understand the material. My function here is not to deliver the material, it's to make you understand it. So please, if you don't understand, if there's anything not clear, let me know. I can give more examples, I can repeat, and so on. Now, from the PDF, can we plot the PDF of fx of x? كيف شكل الPDF شباب؟
rectangle.
Rectangle? No.
No.
Why is it rectangle? أول شيء هذا discrete ولا continuous random variable؟
Discrete.
discrete.
X is discrete, right? Excellent. It's discrete. And because of that, we use the summation. If it is discrete, how does the PDF look like? شباب الديسكريت كيف شكل PDF يكون؟ deltas. Exactly. Stream of deltas. طيب الدلتاز هذه وين مكانها في PDF هذه؟ X for X.
At point -1, 0, and 1.
At -1, at 0, excellent, and at 1. What is the length of the deltas? The size?
1 over
1 over 3.
1 over 3, sorry, all of them. So from the shape of the PDF, it looks like it's symmetric, right? واضح ولا لا؟ شكلها symmetric. يمين مثل يسار وسنترد في النص. Which means that the average value is the median value, which is 0. So either by plotting or understanding كيف شكل الPDF and how does it behave, or by calculation, you should get 0. طيب. Now, let's have an example for uniform random variable y between 0 and 10. Okay? Now find expected value of x. Again, Shwab, send it over the private chat. Calculate this and send it over the private chat. We have a uniform random variable بس عشان اريحكم uniform random variable اللي ما هو اللي ناسي يعني او ما هو 100% متذكر. The PDF looks like this. 1 over 10. It's basically equally likely that the random variable takes any value from 0 to 10. Now calculate for me what is the expected value or the average. يلا يا شباب. How did we do this? Again, most of the answers are wrong. How do we solve this? عندنا الإيكويشن هذه فوق. We integrate over the PDF multiplied by x. So I integrate from minus infinity to infinity x f x of x. Now, what is the PDF and what is the range of the PDF? The integral should be from where to where?
From 0 to 10.
Yes. And what is the value of the PDF?
x over 10.
Yes, this is equal to 1 over 10 هذا PDF and then multiply by x. So the PDF is 1 over 10. X is the same. So x, 1 over 10 is constant. You can get it out. So this is x squared divided by 2 by 20, right? Integrated from 0 to 10. Right?
Yes.
What is this equal to? 100
5.
minus 0 divided by 20, which is 5. واضح شباب من البي دي اف شكلها. This is symmetric again. Around كم? What is symmetric around which number?
5. The
around
middle.
5. واضحة هذه هي. نص هيجي قبل بعد ال 5 والنص الثاني قبل ال 5. So from the shape of the PDF you can see what is the value of the average. However, you can calculate it. Okay. Fine. So going back to our example, if I have the random variable y defined as x squared, and لو تتذكروا x كان discrete, it takes 3 values. هذه PDF حقه. -1, 0, and 1 with equal probability. Then what will be y? What are the values that y can take? I simply go to every value of x and see what is the value of y. So I go to x. X can take -1, 0, and 1. And I calculate y. And I calculate the probability. When -1, when x equal -1, what is y?
1.
شباب. When x equal -1, what is y?
1.
1.
1. It's x squared. When 0, what is y?
0.
And when 1, what is 1? What is y?
1.
1. And the probability of each is what? 1/3, صح? Right?
Yes.
Yes.
However, y takes 1 here and 1 here. So what is the probability of y equal 0?
1/3.
1/3.
It's different at 1. At 1 at 1,
Yes.
2 over 3.
Exactly. The probability of y equal 1 is كم? 1 over 3 هنا 1 over 3 هنا تجمعهم. It gives you 2 over 3. Okay?
Okay.
Now we ask the same question. Find the expected value of x. Now you send it over the private chat نشوف في تحسن ولا لسه. The expected value of y, sorry. Calculate the expected value of y, which is y bar. يلا. طيب شباب quickly. طيب. ممتاز. طيب, so the expected value of y is simply summation I equal 1 to n yi probability of y equal yi, sorry. Which is, I have two values here, either 0 with a probability of 1/3 plus 1 with a probability of come 2/3, right? Which gives me 2/3. This is one way to calculate this. Why? When I know the PDF of y, I know PDF of y. I was able to find it. Suppose that I don't know the PDF of y, and still I want expected value of y. What do? I go to the definition of y. I just use the same expected value. I put x squared. خلينا ناخذها حبة حبة. Y equal g of x. So whatever inside the expected value, the expectation, I replace it with the function of x, g of x. What was the function of x? What was y يا شباب?
X square.
X squared. Excellent. So now I apply the expectation operator with x squared inside. What does x squared inside means? It means that I do the same averaging with the probability x equal xi. However, every time I multiply here by what? xi squared. لما كانت expected value of x I multiplied by xi. لما كانت صارت x squared I multiplied by xi squared. تمام؟ واضحة الفكرة يا شباب؟ And because of that we call this expectation operator. It's an operator. ليش يعني operator? I can operate it on different, whatever I put inside, I can put it here. Now let's calculate this. X can take three values, right? Our value is come -1 square. What is the probability of that? شباب خليكم معي الله يخليكم. 1/3 plus 0 square multiplied by 1/3 plus 1 square. So every value of x I square it multiplied by 1/3. Now let's see what is this. This is 1/3. وهذه 1/3. This is 2/3 plus 0. So it's 2/3. Which is the same as this answer. Same. Except that instead of I have to do it. I can do it two ways. Either I find the PDF of y and then I calculate the average, or I can use the expectation operator directly. واضحة الفكرة هنا؟ So the expectation operator, the way it works of a random variable x, for discrete of a function of a random variable, sorry, E of gx, I simply take gx, I apply it for every xi multiplied by probability of xi. For continuous, I take the gx, I replace it here, and then I do the multiplication and the integration. تمام يا شباب؟ Any question? طيب, so next time inshallah we'll take more examples. Time is up already. أي سؤال يا شباب before we leave?